reflect the quadrilateral, reflect the quadrilateral, we can say it is PQRS through the line, reflect the quadrilateral PQRS through the line y is equal to x, where P11 Q 31 R 33 and S 13. Okay, so this is the example. Reflect the quadrilateral PQRS through the line y is equal to x, where the coordinates of these vertices of a quadrilateral are P11, Q31, R33 and S13. Okay, so same type of example we can solve it by same method. That means first we have to write the position matrix of the quadrilateral PQRS, and that position matrix of the quadrilateral original object is generally denoted by x. So we can say here x is equal to that position matrix of the quadrilateral PQRS. So that we can write it in a column matrix PQRS. So this is the P, Q, R, then S, and their coordinates are as follows. So the coordinate of the point P are 1, 1, then Q is 3, 1, R 3, 3 and S 1, 3. So like that we have the coordinates of the quadrilateral PQRS, and this is the position matrix of the quadrilateral PQRS, which is denoted by X. So once you got the position matrix of the given object, then we have to write the transformation. Okay, so given, or we can write it here. So what is the transformation? The transformation is reflection. Reflect the quadrilateral. So it means the transformation is a reflection. Reflection through what? Reflection through the line y is equal to x. Okay, so this is a standard reflection that already we know the transformation matrix for the reflection through the line y is equal to x. So reflection through the line, reflection through the line y is equal to x. Okay, so what is the transformation matrix for the reflection through the line y is equal to x? So it is a 2 by 2 matrix. Reflection is a 2 by 2 matrix. So that will be generally denoted by T, and it is a 2 by 2 matrix. So how to write the reflection matrix through the line y is equal to x? So that already we seen that. So diagonal entries are 0, 0 and non-diagonal entries are 1, 1 of this 2 by 2 matrix. So like that we can write the reflection matrix through the line y is equal to x. Diagonal entries are 0, 0 and non-diagonal entries are 1, 1. So that is a transformation matrix. Now once you got that T and X, we apply this T on the given matrix X and we'll get the transformed position matrix of the transformed object, position matrix of the transformed object, which will be denoted by X star. Okay, so we can write it here, apply T on X. So we get, see, so what we get it here after applying the T on X. So see there, the formula is X star is equal to X into T. That is our formula, right? So already we know the X and T also. We have the matrix X and matrix T also. So write these two matrices one by one. So the matrix T is X is 1, 1, then 3, 1, 3, 3, and then 1, 3. So this is our matrix X, and then transformation matrix T. T is equal to what? It is a reflection through the y is equal to x line. So which is 0, 1, 1, 0. Okay, so this is our matrix T, and then we have to do the regular matrix multiplication. See there how to do the matrix multiplication of these two matrices. So what will be the matrix now? After taking a matrix multiplication regular, row by column matrix multiplication. So take the first row of the matrix X and take the first column. Now this multiplication you can do it manually easily. So इसके लिए मैट्रिक्स कैलकुलेटर यूज करने की जरूरत नहीं, क्योंकि ये मैनुअली भी इजीली हो सकता है. सो वी कैन मल्टीप्लाई इट मैनुअली. सो फर्स्ट रो फर्स्ट कॉलम. So 1 zeros are 0, 1 ones are 1. So 0 plus 1, 1. Then first row, second column. 1 ones are 1, 1 zeros are 0. So 1 plus 0 is again 1. Okay. So we get it here 1, 1. Then next one is the second row, first column. That is 3, 1, 0, 1. So 3 zeros are 0, 1 ones are 1. So their sum is 1 again. 3 plus 0 plus 1 is 1. Then second row, second column. That is 3 ones are 3, 1 zeros are 0. So 3 ones are 3 means 3 plus 0, that is equal to 3. So we get the second row is 1, 3. Then third row, first column. 3 zeros are 0, 3 ones are 3. So 0 plus 3, that is equal to 3. And then third row, second column. 3 ones are 3, 3 zeros are 0. So 3 plus 0, that is 3 again. And then fourth row, first column. 1 zeros are 0, 3 ones are 3. So 0 plus 3, that is equal to 3. And then third last row, second column. 1 ones are 1, 3 zeros are 0. So 1 plus 0, it is 1. So last row we got it here 3, 1. So this is our matrix multiplication of X into T. And that is our resultant matrix. We can say it is X star. Okay. So X star, or you can denote it by X also. And what is this? So X is the matrix of the quadrilateral PQRS, and after transformation we got the X star. So X star is the matrix of the transformed object or transformed quadrilateral. We can say it is P star, Q star, R star, and then S star. Okay, so P star, Q star, R star, and S star. So that is our resultant matrix. Therefore, what is the coordinates of the P star, Q star? So P star is nothing but 1, 1, Q star is 1, 3, R star is 3, 3, and S star is 3, 1. So we can write it here, the coordinates of this transformed quadrilateral. P star 1, 1, then Q star 1, 3, R star 3, 3, and S star 3, 1. So these are the transformed quadrilateral, P star, Q star, R star, and S star. So that means what? Suppose if we consider the geometrical interpretation of this example. So on the XY plane, suppose this is your x-axis and y-axis, means two-dimensional plane. So this is your x-axis and y-axis. So on this x-axis and y-axis, we have to consider a line y is equal to x. So the line y is equal to x is passing from the origin and divides the first and third quadrant into equal parts. So this is the line y is equal to x. Then if you plot the quadrilateral PQRS, PQRS means original quadrilateral PQRS. So what is that? 1, 1. 1, 1 means we will get it here, that 1, 1 point. Okay, this is our 1, 1. Then 3, 1. 3, 1 is equal to somewhere here. Okay, then 3, 3. 3, 3 is somewhere here, and then 1, 3. 1, 3 is suppose here. So like that we have a quadrilateral PQRS, something like that. Okay, this is our point P, Q, R, and S. That point R should be on the line y is equal to x, and that is reflected through the line y is equal to x. So what happened? This point Q is reflected to S position, S is reflected to Q position. That will be the change. Otherwise, the remaining P and R are the same. So if you observe the matrix X and X star, so the coordinate of the point P and S, P and R are same, but the coordinates of the point Q and S are interchanged. Okay, so like that we get a reflection of the quadrilateral PQRS through the line y is equal to x. Okay, so this is the one example. Now if we are going to take the next example, suppose the example we are taking here, Next one, rotate triangle ABC about about origin through 30° in clockwise direction. In clockwise direction, where A, the coordinate of the point A, I'll consider here, the A is suppose 1 1, B 3 2, and C suppose 3 0. Something like that. We have a triangle ABC. So there is a object is triangle ABC, whose coordinates are given here. The vertices of the triangle ABC, A is 1 1, B is 3 2, and C is 3 0. And this triangle ABC, we have to rotate it about the origin through 30° in a clockwise direction. Now that is important, clockwise direction. So the direction is mentioned here. So clockwise direction means your angle of rotation is negative. Angle of rotation is what? Negative, if it is in a clockwise direction. And if it is in the anti-clockwise direction, then your angle is positive. Okay, so whenever you have to consider the theta, so you have to consider theta as a minus 30°. Okay, it is given 30, but it is mentioned as a clockwise direction, so that's why the angle is a negative if the direction of a rotation is clockwise. Okay, so first we have to write the position matrix. So let X is equal to, X is the position matrix of the original triangle ABC. So what is the position matrix of triangle ABC? A, B and C. So I'll write this position matrix of triangle ABC. So where A is equal to 1 1, B is 3 2, and C is 3 0. Okay, so this is the triangle ABC, position matrix of the triangle ABC. Now the transformation is given what? Transformation is rotation. So we have to write the rotation about origin. Okay, rotation about origin through 30°. Rotation about origin through 30° in clockwise direction. So that is important, clockwise direction. Okay, clockwise direction. So rotation direction is very important. That is theta is equal to, we have to consider theta is equal to minus 30, because it is a clockwise rotation. So clockwise rotation is always a negative angle, and if it is an anti-clockwise rotation, then it is a positive angle. Okay, so now what is the T transformation matrix for the rotation? So T is a 2 by 2 matrix, which we can write it here: cos theta, sin theta, minus sin theta, and cos theta. So this is our 2 by 2 matrix for a rotation about origin. Okay, so here theta is equal to minus 30°. So just we will put the values of theta, that is cos minus 30°, then sin minus 30, minus sin minus 30°, and then cos 30°, minus 30. Okay, so like that we have the transformation matrix. Now just we obtain the values of cos 30, minus 30, sin minus 30, and so on by using the calculator. So calculate the value of sin 30, minus sin 30, cos minus 30, and so on using the calculator. So remember, the angle is in the degree measure. So your calculator must be in a degree mode. Okay, because angle is in a degree measure, so that's why your calculator must be in a degree mode. So what is the value of cos minus 30? So cos minus 30 is equal to 0.8660 if you have calculated by using the calculator. So 0.8660. Then the value of sin minus 30°. So sine minus 30 is equal to minus 0.5. Okay, this is minus 0.5. Then minus sine of minus 30 degree. So that will be plus 0.5. If you are calculating by using calculator, you get this values. And then cos minus 30 is again 0.8660. Okay, so this is our T, transformation matrix T. Now, once you got the T, already we have the matrix X also. Then apply T on X and then calculate the X star. So we'll write it here. Apply T on X. So we get, applying T on X, we get here. So X star is equal to, the formula is to obtain the X star is equal to X into T. Okay, this is our T. Now what is the X? So I'll write it the matrix X here. See, what is the matrix X? 1 1 3 2 3 0. 1 1 3 2 3 0. This is our matrix X. And then T. T is the 2 by 2 matrix. So which is what? 0.08660 minus 0.5, 0.5 and then 0.8660. So 0.8660 minus 0.5, 0.5 and 0.8660. So like that we have the T. Now if you are going to do this matrix multiplication by manual method, so it is quite difficult. So that's why we are doing this multiplication by using calculator. So first you need to enter these two matrices in calculator. So listen to carefully how to enter the matrix and how to take a matrix multiplication using calculator. I'll explain it here once again. Okay, so there. First we have to enter these two matrices in your calculator. So before that, first you have to convert your calculator into the matrix mode. So how to convert it into the matrix mode? So just press the mode button 3 to 4 times. So you will get, there is a option equation, mat, and then vector option. So from them you have to select the matrix option, that is 2. So then it will be converted into the matrix mode or matrix mode. Now we want to enter the matrices first. So to enter the matrix, press shift 4. And in that shift 4, you have to select the dimension first, that is 1 for the dimension, and select the matrix A. So for the matrix A, that is 1, because we are entering the matrix X, which is by the name of A now. Okay, because we can give the name A, B and C only in the matrix. So your matrix X is nothing but matrix A. So what is the dimension? Dimension is 3 by 2 of this matrix X. That means number of rows are 3, number of columns are 2. So M is nothing but the number of rows, which is are 3. Then press equal to sign, then he will ask the N. N means number of columns. So how many number of columns are in the matrix X? That is 2. So then your matrix entries, we have to enter it in the calculator. So A11 means your matrix A was first row, first column entry. So what is your first row, first column entry? 1. Then A12 means first row, second column entry, which is again 1. Then press equal to sign. Then 21, 3. Then 22, that is 2. Then 31, that is equal to 3. And then 32 is 0. So likewise we can enter the matrix X. Okay. Now after that we have to enter the matrix T. So again press shift 4, again go to the dimension option, and then now select the matrix B, because you have to enter this matrix T by the some another name, which is B, because A is your matrix X now. So for a B, select 2, again dimension. So what is the dimension of the matrix T? 2 by 2. This M is equal to 2, and then N is also equal to 2. And then enter the entries of that matrix T. So the first entry is 0.8660, second entry is minus 0.5, third entry is 0.5, and then last entry is 0.8660. So like that we get the matrix B also in your calculator. Now just cancel it everything. Now already whatever the matrix A and B means X and T you are entered, that is stored in your calculator's memory. Okay, so just cancel it everything. Now we are going to take a multiplication of these two matrices A into B. So press shift 4 for that one and select the mat option, because we are selecting the matrix which is already entered in your calculator. So select mat option, that is 3, and which matrix you have to select first? X, which is already be stored by the name A, means we have to select A first. 1, then into, press into, and then again shift 4, select mat option, and then select the matrix B. For the option B it is 2. So we'll get it mat A into mat B, and press equal to sign, so you will get the entries of the resultant matrix. So the first entry of the resultant matrix is what? So 1.3660, 1.3660. Then second entry is 0.3660, 0.3660. Then next entry is 3.5980, 3.5980. Then next one 0.2320, 0.2320. Next third row entry 2.5980, 2.5980, and the last entry 1.5 or 1.500, you can write it. So this is your resultant matrix, means multiplication of x into t, which is x star. Okay, so this is the transformed object of triangle ABC, which is denoted by A star, B star, and C star, right? So your A star, coordinate of the transformed object A star is become what? A star is nothing but 1.3660, and the second coordinate is 0.3660. Okay, B star is equal to 3.5980 and 0.2320, and C star is equal to what? 2.5980 and 1.5. Okay, so this is your transformed triangle. Clear? So this is your transformed triangle A star, B star, and C star. Means rotating the triangle ABC about origin through 30° in clockwise direction. So after rotation about origin by minus 30° means in clockwise direction, we get the triangle A star, B star, C star. And this is the position of the triangle A star, B star, and C star. So that is the example. Okay, end of this example. So likewise we can find out the transformed object by this way.